Welcome to today's session. Just a forward-looking statement. So today we'll understand what does it really mean by get your data AI ready, right? So we'll understand how knowledge graphs are going to help with your getting your AI ready, data AI ready, and we'll also talk about GraphRAG and how knowledge graph is going to help GraphRAG to have a lot more explainable responses. I'm Pramod Borkar. I'm part of the product team at Neo4j. So before I dig in, right, let's go into the AI evolution a little bit. So we have generative AI models, the large language models, been in the industry for a while now, right? So that has the ability to respond to your queries, right? But they're really still prone to hallucinations, especially when you're dealing with your enterprise data, right? That's where you have RAG architecture, RAG pipeline, where you can ground your responses, right, from accurate data sources. Once RAG is in place, you still need to connect to multiple data sources, right? Apply logic, manage your workflows. This is where the AI agents come into play. The next wave is the knowledge graph, where you still need to provide all the context, and you still need to have a flexible query depth to it, right? That's where the knowledge graphs come in. So this talk is all about why knowledge graph is going to help you make the data AI ready, right? So we all know the AI is been in the market for a while, but if you look at it, and every conference talks about it, but if you look at it, most of the organizations are still stuck piloting the GenAI projects. Why is that the case? So it's basically a data management issue, right? If you look at it, 85% of the IT leaders still cite data quality as the main challenge. So I've bucketed that into three buckets. One is the data organization problem, where your data still need to organize, right? It has to be well organized to function efficiently. It needs to still have all the standardization. You can't have a messy, inconsistent data. You still need to have data across multiple tools, but you can't. AI really doesn't work well with different formats, different schemas, and all of that, right? So that's where you need a standardization. Most of the data management tools have figured out some ways to figure that out, your data organization and standardization. The third one, which is basically the crux of this talk, is your query diversity problem, right? What I mean by that, let's say you ask a question where you have like a lot of questions being asked to the AI and AI agents. It's a wide variety of different questions. Is your database or is your data platform ready to answer that question, right? That's your basically a query diversity problem. For example, I can ask a question like, why did my revenue drop in EMEA, right? So you need to connect your finance, your sales, your market data, your support data to answer that question. So that's a query diversity problem. That's a crux of this talk. So how do you solve that? How do you make, so these are the challenges we have. And how do you solve that problem, right? So what makes AI ready? So if I solve that problem, it sort of makes AI ready. So the data has to expose, it has to have a lot more context to the data. It needs to be flexible, meaning it has to adapt to the new challenges of data questioning, data coming in. It can be unstructured, structured data. We don't know what's coming in, so it has to be flexible. And obviously it has to have the data governance in place. So this is where the knowledge graphs come in, where by definition, it's a design pattern to organize and you access your connected data or your interrelated data, right? Think of a CRM application, for example, right? A CRM application has, you don't just load the customer records. You want to understand how the customer is connected to your accounts, your support tickets, your reps, your external data, your contract history, all of that, right? So that sort of becomes your CRM knowledge graph. You can have domain-specific knowledge graphs like a financial knowledge graph or a supply chain knowledge graph. So how do you represent that? So the way we represent that is something called as a property graph model, where instead of tables and joins and columns, you have something called as nodes. Nodes is entity. For example, if I take a financial transaction, so your accounts is a node. Your bank is a node, right? So the relationship between those two, that's how it's represented. It's a relationship between two entities. And you can have properties with it, right? For example, if I have a transaction on that particular date, date can be a property, right? That's how it's inherently stored in a graph database. It's also flexible, right? I can add nodes, I can add relationships, I can delete, I can update, I can add properties to it. It's just flexible, it can add automatically. So that's your graph model, right? That's how you represent a graph model. So we are saying knowledge graph is basically AI-ready data. The reason is it has a lot more context now, right? Now, all the nodes and relationship that we talked about, they're actually stored inherently within your graph database. You don't have to create indexes. You don't have to create joins. That's how they're stored. So that makes it much faster to retrieve data, right? So I talked about query diversity. That comes into play. So query diversity, now I can do a multi-hop reasoning question, for example. I can do a multi-hop query to understand the data very efficiently. It's also flexible. I can add nodes, relationships, whatnot, very easily with the knowledge graphs. It's also standardized. So we have something called a GQL, which is something equivalent to a SQL. It's an ISO standard query language. Now you can pull that information very easily from the graph database, right? So going to the architecture a little bit. So knowledge graphs basically it can be a source for your retriever, where in your RAG pipeline, you can have a knowledge graph as a very strong source. And that can lie between your data platform like Databricks, for example, where you can pull in information from Databricks. It can be unstructured or structured data, and create a knowledge graph. Now you can create a supply chain knowledge graph. You can create a financial knowledge graph, right? And that can be a retriever as a source. And that you can act as a source to talk to the LLMs now, right? So just real quick, if I talk to a traditional RAG architecture, you have a question, you have a prompt, and your retriever sits between your prompt and your LLMs, right? And basically you're sourcing it traditionally you're sourcing it from a vector database, right? What we're saying now is a GraphRAG is nothing but a RAG architecture. It's a retrieval-augmented generation using knowledge graph as a source. So this improves your accuracy a lot more. If I go back to the accuracy real quick, so we have a lot of studies done where it's 3x more accurate than a traditional RAG architecture, right? So you can look at all the sources, you can look at all the research papers here, you'll get the information. But going back, you not only have a lot more accuracy, a lot more context with the knowledge graph, but now because you have a graph database, you can have community patterns, you can have enhanced vector search, for example. You have a lot more advantages using a graph database, right? So these are just some of them, these advantages are listed here. But I can do a dynamic query generation. For example, if I have a question to the LLMs, and now it does not have that information, I can do a dynamic query generation with the text to cipher, for example, right? So it has a lot more advantages using just the graph database. So with Databricks, we have a Spark connector with Databricks. So now I can get your unstructured and structured data from Databricks, create a knowledge graph within Neo4j, and that can act as a retriever source, right, in your RAG pipeline, in the GraphRAG pipeline. So together we have a lot of customers. We have 165 plus that's growing. We also have popular use cases. Again, going back to the knowledge graphs, any financial or a supply chain, any domain-specific knowledge graph, you can turn that to a knowledge graph. And then once you have a knowledge graph, you can do whatever you want to, right? You can query, you can do multi-hop reasoning and all of that in your pipeline. So going to one step further as to why GraphRAG is more explainable, right? On the left, you'll see a symbolic representation in a graph database. Here, I'm just taking an example of apples and oranges as fruits. And that's how it's represented in a graph database, right? Whereas in a vector database or a sub-symbolic method, it's basically a vector representation. It's a bunch of numbers. That's how you do it. The advantage or disadvantage of that is it's basically a vector distance search, right? You're doing a semantic search on the implicit or a vector database. Whereas in the graph database like Neo4j, you can not only do that, you can just run a simple query and get the information. You don't have to do a semantic search, right? You can also do a lot more with it. You can do a node similarity search. I can do a community nodes and then compare those two communities now. You can do a lot more with graph databases, right? So if I have to go explicit, now you not only have apples and oranges, but you have like a lot more information connected to the link, right? Now I can do a multi-hop reasoning with graph databases. Whereas with the vector DB only, you can just do an approximate search or semantic search, right? That's a big advantage. So what does this look like in practice, right? So we have one customer example where it's a big giant a company where a gaming company where they want to understand. They had disparate data sources, right? Now they brought everything to one, like Uber knowledge graph. Now they can answer questions like, how my market conditions are affecting my revenue, right? So that's a very tough question to ask, but now it's very easy, right? Because they have connected to a knowledge graph, right? How different promotions affect player engagement, for example, that's another difficult question. So these questions can be answered very easily with a knowledge graph, right? That's where I was talking about the query diversity. Now you can do a multi-hop query diversity and answer those questions, right? So let's get to a quick demo here. What you're seeing here is energy grid information. It's represented in a traditional way, right? It's a bunch of tables and columns and joins. If I transform that to a graph, that's how it looks like in a graph. So on the left, you'll see an energy grid. It has bus, transformers, sensors, all that information. On the right, it can be documents. It can be installation manuals, right? And that can be turned into a text embedding and stored in the graph database, right? So you have both unstructured and structured. You can store that information in a graph database. Once you have that, now I can do queries. I can do in here. I'm just running a very simple query to get all the information. If I look at this now, I'll just stop here. If you look at this, is how your energy grid is represented, visualized in a graph database, right? If you see, now I can do, without knowing anything, I can just have one node. I can do a multi-hop query without knowing anything, right? That's the beauty of a graph database. It's just a pointer lookup. I don't have to have joins. I don't have to know the table names, for example. I can just know one information, one sort of entity, and then do a multi-hop query. So that's a basic essence of why knowledge graphs are important, right? It also has all the bunch of properties in it, like we talked about. So now you can also do analytics on top of it, right? So now I can run. This is almost like a Power BI analyst reports. I can do reporting on the data now, right? I can understand why my energy network, the risk scores, all of that, right? So I can do a bunch of reports on this data. For example, I can understand what's my risk score on the grid, how's the networking, how's the customer installing the grid, what are the issues, what's the network map, what's the maintenance map, all of that, right? So that's great. Next, I want to show you how this is the NeoConverse. It's basically a tool where you ask a question in a natural language, and it turns into a Cypher query, right? So this is just it's not a production environment tool. It's a part of labs. What we're doing is we are trying to mimic the AI agents. So if I go back here, so what you're seeing here is sort of mimicking the AI agents, right? So I want to get installation records. I want to get the maintenance records, right? So they can be agents talking to different data sources. In here, we're just trying to mimic it's all going to the one database. But in reality, this can go to a different data sources, right? So now I can ask a question. For example, I'm asking a very difficult question, a very complex question. I want to list all the, I can't read it here. I want to list all the equipment, sensors information, right? So what happens is on the right, you'll see a bunch of queries that gets kicked in because of the agents. And now you can answer those questions very easily with the graph database, right? So it's a very complex question, but now you have a bunch of these agents acting on that behalf and then getting answers to those very complex questions. That's a query diversity problem I was talking about. That's what knowledge graphs will solve, right? And I can ask a bunch of questions. This is just an example of how we can do it. And yeah, that's it. Basically knowledge graphs, it provides you a lot more context flexible standardization, right? And then that helps in turn the GraphRAG architecture where it's a lot more accurate now because of the knowledge graphs. It's a lot more explainable, right? So yeah, that's all we have. If you have any questions, you can come by the booth. We have an actual demo of the energy grid that I was talking about. We have a lot more, and then we also have a RAG and GraphRAG differences. So you can come to the booth and talk about it. Thank you.